rollout from the vehicle assembly building signals that launch is near. Sitting atop the mobile launcher, the crawler transporter moves along the crawlerway towards historic Launch Pad 39B at the Kennedy Space Center at a top speed of 1 mile an hour. After traveling over 4 miles, the rocket and the spacecraft climb up a ramp and are positioned over a flame trench. Once in position, the mobile launcher is lowered onto support post and the crawler is rolled away to a safe distance. Final checks are performed at the pad, including crew cabin closeout via the access arm sitting over 300 feet above the surface of the launch pad. The launch date is set, and the teams are prepared for the mission that is about to occur. It's sunrise on launch day. Engineers in the Launch Control Center have already powered up the spacecraft and the rocket and loaded the core stage and upper stage with cryogenic fuel. As launch window open approaches, final checks are performed, and when all systems are go, terminal countdown is initiated. The big physics of launch are about to be put on full demonstration. Umbilical plates weighing hundreds of pounds await their cue to retract to clear the path of the rocket at liftoff, some mounted on arms the size of tractor trailers. The mighty core stage engines are prepared for engine start as they are thermally conditioned for an onrush of cryogenic fuel in the heat of ignition. At T-minus 15 seconds, sound suppression is activated, cascading water into the flame trench to dampen the acoustic shock. And as the core stage engines achieve full throttle, shock diamonds appear. At booster ignition, the flame trench is flooded with fire. At first motion, all umbilical arms are retracted and the rocket clears the tower in just seconds. At liftoff, the vehicle produces 8.8 million pounds of thrust and lofts the vehicle weighing nearly 6 million pounds and standing 32 stories tall to orbit. Propelled by a pair of 5-segment boosters and 4 liquid engines, the rocket achieves maximum dynamic pressure only 90 seconds into the mission, the period of greatest atmospheric force on the structure of the rocket. Thousands will gather in Florida to watch our ship get smaller and leave the Space Coast behind. Approximately 2 minutes into the mission, the boosters will have consumed all of their solid propellant and are safely jettisoned. The rocket will continue on, guiding itself to orbit with magnificent precision. Just 3 minutes into the mission, the service module fairings are jettisoned to lighten the vehicle and expose Orion's solar arrays. Just 40 seconds later, the launch abort system is also jettisoned. It is no longer needed. Orion could safely abort at any time. Once at the desired velocity target, the core stage engines are shut down and the core stage separates. The interim cryo-propulsion stage with Orion will continue to orbit the Earth. Along the way, they will pass through the altitude of the International Space Station at 250 statute miles. During this first orbit, the solar arrays are deployed so that Orion no longer needs battery power. It can now produce its own power. Following solar array deployment, the arrays are positioned into a load-bearing configuration to prepare for the perigee raise maneuver. The raise maneuver will ensure an Earth orbit and use the thrust provided by the interim cryo-propulsion stage. Once the perigee raise maneuver is complete, Orion systems are checked prior to committing to the translunar injection, or TLI maneuver. The TLI maneuver must be successfully completed to depart Earth orbit. The TLI burn is approximately 20 minutes in duration and increases the spacecraft's velocity over 9,000 feet per second, a speed change faster than a high-powered rifle bullet travels. Following TLI, Orion is committed to a lunar trajectory, just 1.5 hours after launch. Once complete, the spacecraft adapter will remain with the interim cryo-propulsion stage, and they will separate from Orion. As Orion departs low Earth orbit, it will fly through the orbital debris field encircling the Earth, past the global positioning navigation satellites, past the communication satellites in geostationary orbit, and through the Van Allen radiation belts, on into the deep space radiation environment. Orion is now entering an outbound coast phase. The spacecraft is uniquely designed to navigate, communicate, and operate in this deep space environment. The outbound coast to the Moon will take approximately 4 days. As Orion approaches the Moon, the service module will be used to perform a critical lunar gravity assist maneuver, allowing the ship to enter a distant retrograde orbit about the Moon. The Moon will get larger and larger in the window, and at closest approach, Orion will be just 62 miles from the surface of the Moon. As the spacecraft flies around the far side of the Moon, we will lose all communication back on Earth, and for a period of time, Orion will be on its own. Mission Control will await acquisition of signal, and as we lock on, a new generation will see their first Earthrise. The spacecraft is now in the distant retrograde orbit, where its systems will be tested in the deep space environment for over a week. Along the way, our ship will travel farther from Earth than any human-capable spacecraft has ever gone. At the farthest point, Orion will be some 1,000 times farther from Earth than the International Space Station, at over 270,000 miles away. Teams in Mission Control Houston and at Naval Base San Diego will prepare for Orion's return home, and the recovery ship will set sail for the recovery zone in the Pacific Ocean. Orion will exit the distant retrograde orbit with another lunar gravity assist and service module engine firing. Along the way, the trajectory will be adjusted to target the Earth's thin atmosphere at over 250,000 miles away and ensure a precision landing in the Pacific Ocean following a direct entry. During the coast home, Orion will maintain the desired tail-to-sun attitude to optimize spacecraft cooling and maximize power production in the deep space environment. Another 4 days return coast home to Earth. As our home planet fills the windows of Orion, an important contribution from our European partners called the service module has done its job. The service module is jettisoned and separates. Following separation, the world's largest heat shield will be oriented into the direction of travel to prepare for entry interface at an altitude of 400,000 feet. At entry interface, Orion will hit the Earth's atmosphere traveling at a speed of 24,500 miles an hour and decelerate at up to 9 times the force of gravity. The heat shield will protect the spacecraft from temperatures half as hot as the surface of the Sun, approaching 5,000 degrees Fahrenheit. Orion will continue to decelerate, pass through the sound barrier, and announce its arrival to the waiting recovery team with a sonic boom. Following peak heating, a protective thermal cover that sits over the parachutes will be jettisoned. This begins a series of parachute deployments. The drogue chute deployment series is designed to stabilize and slow the spacecraft, and in a period of less than 20 minutes, Orion will slow from a speed of Mach 32 to 0 at splashdown. The 3 main parachutes will deploy and slowly unfurl and suspend the 22,000-pound capsule and allow it to gently descend to the surface of the ocean. After 25.5 days and a total distance traveled exceeding 1.3 million miles, a precision landing within eyesight of the recovery ship. Following splashdown, Orion will remain powered for a period of time as Navy divers approach in small boats from the waiting recovery ship. After a brief inspection for hazards, the divers will hook up tending lines and a tow line. The capsule will be then towed into the well deck of the recovery ship, and once the capsule clears the stern gate, the gate will be closed, the well deck will be drained, and we will bring our ship home.